you guys, this is Mrs. Bolin here with your notes for section 9.1, properties of exponents, the first day. We're going to start with a basic warm-up, just reviewing some prior learning that's going to tie into what we're doing today. So for question number 1, we have 2 squared. Remember, that just means 2 times 2, which is 4, easy peasy. 3 squared just means 3 times 3, which is 9. 4 to the third means 4 times 4 times 4. I know that the first two 4s make 16, and 16 times 4 equals 64. Then I have 5 to the third. Try to focus that a little bit better, you guys. Sorry about that. And then I have 5 to the third, which just means that I have 5 multiplied by itself 3 times. 5 times 5 is 25. And then times by that last 5, if I had 5 quarters, I'd have $1.25. So that's our warm up, just to go over what exponents are and how do you write them in expanded form and how do you solve them. So for our exploration, what we're going to look at is stuff that we already know. Okay, 2 to the fourth is just 1, 2, 3, 4 twos. Well, I know 2 times 2 is 4, times 2 is 8, times 2 is 16. I know 2 to the 3 is 2 times 2, which is 4, times 2, which is 8. I know 2 squared means that I have 2 2's, which is 4. And then the question is, you guys, what pattern do we see from 16 to 8 to 4? It goes divide by 2, divide by 2, divide by 2, right? Whatever I'm multiplying by, that's what I'm dividing by. Let's see if that holds true for the 5s. 5 to the 4 would be 5 times 5 times 5 times 5, which would be, we already know that the first 3 of them make 125. And if I have that 5 times, I get 625. And then I would do 5 times 5 times 5. We already did that in our warm-up. We know is 125. We know that 5 times 5 is 25. This one didn't divide by 2. It divided by 5, right? So whatever my base is, that's what it's dividing by each time, which makes sense because each time the number goes up, I'm multiplying by another 5. So if I'm trying to take that pattern down, I would divide by another 5. So let's look at it with tens. Tens are the easiest because all you have to do is look at the exponent, and that's how many zeros you put. So 1, 2, 3, 4. This one has 3. This one would have 2. And again, it follows the same pattern by 10 each time. Okay, so if we're going to extend that on down a little bit, so if I just have 1, 2, well, that's easy. It's just 2. If I keep dividing by 2, what's going to happen? 2 divided by 2 is 1. 1 divided by 2 is 1/2. A half divided by 2 is a fourth. So we're going to continue that pattern for the 5s and the 10s just to see what it looks like when we apply that to different numbers. So if I'm going to divide by 5, we know that this one's 5. That pattern still works. 5 divided by 5 is 1. If I divide that by 5, I get 1/5. And if I divide that by 5, I get 1/25. Now I'm going to do the same thing for 10s. If I have 1 0, that's 10, right? We divided by 10. 10 divided by 10 is 1. I have no zeros. Well, remember, this means divide by a 10. So 1 divided by 10, 1 divided by 2 tens. Okay, so what do you notice about the negative exponents? It's the same answer as our positive exponent, but it's in the bottom of the fraction. Okay, so when we have a negative exponent, it kind of means divide by that number that many times. Okay, so here's our actual rules. Look at everything to the 0 power. It equals 1. 1. Okay, so anything to the 0 power is equal to 1. With the exception, if you had 0 to the 0, that's undefined. Because 0 to anything is 0, but anything to 0 is 1, so those two would have some problems right there. Okay, negative exponents for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n, meaning it's 1 over that value. Okay, reciprocal just means 1 divided by. Okay, a to the n. All right, so let's do some problems together. And you guys, this seriously is like my favorite chapter because as far as work goes, the work is pretty easy, but there's a lot of different rules. And so understanding why you have the rules will help you to remember them way better than trying to memorize formulas. Okay, so remember, anything to the 0 power is equal to 1. Remember here that the negative exponent just means I'm dividing by 3 threes. One thing that I say is, okay, well, the negative tells you that it's unhappy where it is. So we need to move it. If it was on the top, we'd move it to the bottom. If it's on the bottom, we move it to the top. So it's unhappy where it is. Now that I move it, it is nice and happy and positive. And then we're just going to multiply that out. 3 times 3 is 9, times 3 more is 27. All right, looking at this top one, this one's a little bit trickier, okay? The 5 to the 0 just equals 1. Okay, so that part is just times by 1. That doesn't really matter. Well, remember we had a negative on the top, so it moved to the bottom. What happens if it's unhappy in the bottom? Where should we move it? Top? Okay, remember that we're talking about the reciprocal. Okay, so if currently it's being divided by that, then the reciprocal would flip it up to the top. Okay, so we have a positive 2 to the 2 on the top of the fraction. Because we have nothing left in the bottom, we don't need to put anything else there. If you ever have nothing left in the top, you still need the 1 to save your spot. But in the bottom, we don't need to write divide by 1. But we do need to actually multiply this out, and so we get 4 for our answer. That's not a very good box. Sorry about that. And I forgot to box that first answer. All right, let's do the next couple that have x's in them instead of numbers. So remember, anything to the 0 power equals 1. Doesn't matter if it's a y or the square root of 72. If it's to the 0 power, it equals 1. This one you need to be really careful with, okay? Because this negative 5 is attached to the x. It is not attached to the 2. This 2 is being multiplied by x to the negative 5. If it were supposed to go to the 2, it would have parentheses around it, but there are not. So that 2 is happy as a clam right where it is. The x is unhappy in the top. It's negative. So we're going to move it to the bottom where it's now super happy and positive. So x to the 5th. Since I don't know what x is, I can't actually do x times x times x times x times x, however many, that's 5. I can't do that. So we just leave it x to the 5th, but we make sure that we write it with positive exponents. We always want to move it, make it happy. Okay, so we're going to leave it like that. Question number 6. Anything to the 0 just equals 1 times by 1 does not change my answer at all. So I can just kind of get rid of that for right now. If you want, you could put a 1 there if that helps you remember, but again, not super necessary. Remember, each one of these parts of the product of a term has its own exponent. So like for instance, there's no exponent there. So it's like the y has like a 1. Okay, in which case it would just stay right where it is. But that x is unhappy in the top. So we move it to the bottom and now it's happy. All right, or you could, for mathy terms, I know happy and unhappy aren't really like math operations. So you could say we're going to take, it has a negative exponent, so we're going to take the reciprocal. So instead of by multiplying by x to the negative 2, that's actually equal to the reciprocal of x squared. Okay, so now we're going to go ahead and go over the odd answers to your homework. See, you guys, look, I didn't even, look at all that white space. I didn't even have to do hardly any work. All right. So we're going to do the odd ones. I'll see if I can remember to stop on the odd ones and not do all the evens too. Okay, so for question number 1, we should only have positive exponents. If it's ever a number, we kind of want to simplify and get the simplest number we can. So I know this is a negative, so I'm going to write it using the reciprocal of 3 to the 4th. Or I could also think about it is unhappy in the top. It's so negative. So then once we move it to the bottom, now it's nice and positive. But then we do want to simplify that. 3 times 3 is 9, and times 3 is 27, times 3 is 81. Or you can think about if I've got 4 3s and I've got 2 groups of 2 3s, and 9 times 9 is 81. 81. Okay, and that is our answer. Question number 2, I'm going to skip, but anything to the 0 power equals, just fill that in, super easy. Okay, question number 3, we've got another reciprocal problem. So it's negative, unhappy in the top. I'm going to move it to the bottom. Now it's nice and happy and positive, but then I need to, it's not 8, you guys, not 8. Remember, it means 2 times 2, which is 4, times another 2, which is 8, times another 2, which is 16. If you ever have a hard time with that, write out 4 little 2s and just cross them off as you're done multiplying them. Okay, now we're going to move down into some letters. So look at problem number 5. And it is negative, unhappy. So we know we're going to have to utilize the reciprocal. Here's the nice thing about exponent 1. I don't actually have to write it. If you want to put a little 1, you can, but you don't need to. 1 over p is the final answer there. Question number 6, I'm going to skip because it is an even number, but it's just like number 7. So if you're not sure how to do number 6, look at the answer to number 7 and see if you can do the same thing to problem 6. So this big 2 stays where it is. The m to the negative 2 is the part that's unhappy where it is. So we move it to the bottom. Now it's happy. It goes from being negative to positive. Again, a negative exponent is just the reciprocal of m to the 2. So that is our final answer. Oh, I didn't box the last couple of those. My bad. Okay, we're going to skip number 8, but it's pretty similar to number 9. So that 4 is happy, so it's going to stay where it is. The x is happy, so it's going to stay where it is. The only thing moving down to the bottom is the y, because it has a negative exponent. So y is now positive because we've moved it to the bottom. Okie dokie, you guys. Question number 11, and we are just moving right along. Feel free to pause me anytime if I am going too fast. Question 11, the a is happy where it is because its exponent is positive. So we leave a on the top with its exponent. B, unhappy, it's being super negative where it is. So we want to move it to the bottom where it can be positive. And we keep the same value. We just change it from a negative to a positive as soon as we move it. Question 12, we're going to skip that one. But as you guys know, I'm just going to help you guys out here. That equals 1. Anything divided by 1 is just itself. So you're welcome. Question number 13, anything to the 0 equals 1. The 0 only goes with the c, okay? So the 2 is still there. There's no parentheses around it. So the 0 only applies to the letter that it's stuck to. Okay, so 2 stays where it is. The a to the 3rd is going to move out of the bottom, out of the denominator into the numerator. So we're going to put it up here to a to the 3. I don't have anything left in the bottom, so I don't have to put anything down there. You could put over 1, but this is the simplified answer. We're going to skip number 14, but that's going to be kind of similar to what we've been doing. Question number 15, that equals 1. So we don't need to times by 1. 2 times 1 is still just 2. And again, this is negative in the bottom, so we're going to move it up to the top, and now it is positive. That is it, you guys. This chapter is way easier than last chapter, right? You're like solving with elimination and doing all that fun stuff. Anyways, I hope you guys have a great day. See you tomorrow.